Internet Message Access Protocol is a protocol for email retrieval and storage developed by Mark Crispin in 1986 at Stanford University as an alternative to POP. IMAP, unlike POP, specifically allows multiple clients simultaneously connected to the same mailbox, and through flags stored on the server, different clients accessing the same mailbox at the same or different times can detect state changes made by other clients. Email protocols. The Internet Message Access Protocol is an application layer Internet protocol that allows an email client to access email on a remote mail server. The current version, IMAP version 4 revision 1, is defined by RFC 3501. An IMAP server typically listens on well-known port 143. IMAP over SSL is assigned well-known port number 993. IMAP supports both online and offline modes of operation. Email clients using IMAP generally leave messages on the server until the user explicitly deletes them. This and other characteristics of IMAP operation allow multiple clients to manage the same mailbox. Most email clients support IMAP in addition to Post Office Protocol to retrieve messages. However, fewer email services support IMAP. IMAP offers access to the mail storage. Clients may store local copies of the messages, but these are considered to be a temporary cache. Incoming email messages are sent to an email server that stores messages in the recipient's email box. The user retrieves the messages with an email client that uses one of a number of email retrieval protocols. Some clients and servers preferentially use vendor-specific, proprietary protocols, but most support SMTP for sending email and POP and IMAP for retrieving email, allowing interoperability with other servers and clients. For example, Microsoft's Outlook client uses MAPI, a Microsoft proprietary protocol to communicate with a Microsoft Exchange server. IBM's Notes client works in a similar fashion when communicating with a Domino server. All of these products also support POP, IMAP, and outgoing SMTP. Support for the Internet Standard Protocols allows many email clients such as Pegasus Mail or Mozilla Thunderbird to access these servers, and allows the clients to be used with other servers. History: IMAP was designed by Mark Crispin in 1986 as a remote mailbox protocol, in contrast to the widely used POP, a protocol for retrieving the contents of a mailbox. IMAP was previously known as Internet Mail Access Protocol, Interactive Mail Access Protocol, and Interim Mail Access Protocol. Original IMAP, the original Interim Mail Access Protocol was implemented as a Xerox list machine client and a TOPS 20 server. No copies of the original Interim Protocol specification or its software exist. Although some of its commands and responses were similar to IMAP2, the Interim Protocol lacked command response tagging and thus its syntax was incompatible with all other versions of IMAP. IMAP2, the Interim Protocol was quickly replaced by the Interactive Mail Access Protocol, defined in RFC 1064 and later updated by RFC 1176. IMAP2 introduced the command response tagging and was the first publicly distributed version. IMAP3 IMAP3 is an extremely rare variant of IMAP. It was published as RFC 1203 in 1991. It was written specifically as a counterproposal to RFC 1176, which itself proposed modifications to IMAP2. IMAP3 was never accepted by the marketplace. The IESG reclassified RFC 1203 Interactive Mail Access Protocol, version 3 as a historic protocol in 1993. The IMAP working group used RFC 1176 rather than RFC 1203 as its starting point. IMAP2 bis, with the advent of MIME, IMAP2 was extended to support MIME body structures and add mailbox management functionality that was absent in IMAP2. This experimental revision was called IMAP2 bis. Its specification was never published in non-draft form. An Internet draft of IMAP2 bis was published by the IETF IMAP Working Group in October 1993. This draft was based upon the following earlier specifications: Unpublished IMAP2 bis. TXT document, RFC 1176, and RFC 1064. The IMAP2 bis. TXT draft documented the state of extensions to IMAP2 as of December 1992. Early versions of Pine were widely distributed with IMAP2 bis support. IMAP4, an IMAP working group formed in the IETF in the early 1990s, took over responsibility for the IMAP2 bis design. The IMAP-WG decided to rename IMAP2 bis to IMAP4 to avoid confusion with a competing IMAP3 proposal from another group that never got off the ground. The expansion of the IMAP acronym also changed to the Internet Message Access Protocol. The latest version, IMAP4, allows an email client to manipulate email messages stored on a server in the same way as a client using local folders. This ability allows multiple clients for a single user to see the same mailbox status. For example, if a user moves a message from the user's inbox to some other folder using one client, when later accessing the mailbox from another client, the message appears in the folder to which it was moved. Advantages over POP, connected and disconnected modes of operation. When using POP, clients typically connect to the email server briefly, only as long as it takes to download new messages. When using IMAP4, clients often stay connected as long as the user interface is active and download message content on demand. For users with many or large messages, this IMAP4 usage pattern can result in faster response times. Multiple clients simultaneously connected to the same mailbox. The POP protocol requires the currently connected client to be the only client connected to the mailbox. In contrast, the IMAP protocol specifically allows simultaneous access by multiple clients and provides mechanisms for clients to detect changes made to the mailbox by other, concurrently connected, clients. See for example RFC 3501 Section 5.2, which specifically cites simultaneous access to the same mailbox by multiple agents as an example. Access to MIME message parts and partial fetch. Usually all Internet email is transmitted in MIME format, allowing messages to have a tree structure where the leaf nodes are any of a variety of single-part content types and the non-leaf nodes are any of a variety of multi-part types. The IMAP4 protocol allows clients to retrieve any of the individual MIME parts separately and also to retrieve portions of either individual parts or the entire message. These mechanisms allow clients to retrieve the text portion of a message without retrieving attached files or to stream content as it is being fetched. Message state information. Through the use of flags defined in the IMAP4 protocol, clients can keep track of message state, for example, whether or not the message has been read, replied to, or deleted. These flags are stored on the server, so different clients accessing the same mailbox at different times can detect state changes made by other clients. POP provides no mechanism for clients to store such state information on the server, so if a single user accesses a mailbox with two different POP clients, state information such as whether a message has been accessed cannot be synchronized between the clients. The IMAP4 protocol supports both predefined system flags and client-defined keywords. System flags indicate state information such as whether a message has been read. Keywords, which are not supported by all IMAP servers, allow messages to be given one or more tags whose meaning is up to the client. IMAP keywords should not be confused with proprietary labels of web-based email services, which are sometimes translated into IMAP folders by the corresponding proprietary servers. Multiple mailboxes on the server. IMAP4 clients can create, rename, and/or delete mailboxes on the server, and copy messages between mailboxes. Multiple mailbox support also allows servers to provide access to shared and public folders. The IMAP4 Access Control List extension may be used to regulate access rights. Server-side searches. IMAP4 provides a mechanism for a client to ask the server to search for messages meeting a variety of criteria. This mechanism avoids requiring clients to download every message in the mailbox in order to perform these searches. built-in extension mechanism, reflecting the experience of earlier Internet protocols. IMAP4 defines an explicit mechanism by which it may be extended. Many extensions to the base protocol have been proposed and are in common use. IMAP2 BIS did not have an extension mechanism, and POP now has one defined by RFC 2449. Disadvantages: while IMAP remedies many of the shortcomings of POP, this inherently introduces additional complexity. Much of this complexity is compensated for by server-side workarounds such as maildir or database backends. The IMAP specification has been criticized for being insufficiently strict and allowing behaviors that effectively negate its usefulness. For instance, the specification states that each message stored on the server has a unique ID to allow the clients to identify the messages they have already seen between sessions. However, the specification also allows these UIDs to be invalidated with no restrictions, practically defeating their purpose. Unless the mail storage and searching algorithms on the server are carefully implemented, a client can potentially consume large amounts of server resources when searching massive mailboxes. IMAP4 clients need to maintain a TCP/IP connection to the IMAP server in order to be notified of the arrival of new mail. Notification of mail arrival is done through in-band signaling, which contributes to the complexity of client-side IMAP protocol handling somewhat. A private proposal, Push IMAP, would extend IMAP to implement push email by sending the entire message instead of just a notification. However, Push IMAP has not been generally accepted and current IETF work has addressed the problem in other ways. Unlike some proprietary protocols which combine sending and retrieval operations, sending a message and saving a copy in a server-side folder with a base-level IMAP client requires transmitting the message content twice, once to SMTP for delivery and a second time to IMAP to store in a sendmail folder. This is remedied by a set of extensions defined by the IETF Lemonade Working Group for Mobile Devices, Alauth and Catenate in IMAP and Bell and SMTP submission. POP servers don't support server-side folders, so clients have no choice but to store sent items on the client. Many IMAP clients can be configured to store sent mail in a client-side folder, or to BCC oneself and then filter the incoming mail instead of saving a copy in a folder directly. In addition to the Lemonade Trio, Courier Mail Server offers a non-standard method of sending using IMAP by copying an outgoing message to a dedicated outbox folder. Security: STARTTLS can be used to provide secure communications between the MUA communicating with the MSA or MTA implementing the SMTP protocol. Dialog example: this is an example IMAP connection as taken from RFC 3501 Section 8. C. Open connection. S. OK IMAP4 Rev1 service ready. C. A001 login MSC secret. S. A001 OK login completed. C. A002 select inbox. S. 18 exists. S. Flags. S. 2 recent. S. OK. Unseen 17. Message 17 is the first unseen message. S. OK. With validity 3,857,529,045, UIDs valid, S, A002 OK, read-write select completed, C, A003 fetch 12 full, S, 12 fetch internal date July 17, 1996. 244 on 25 seconds -0700, RFC 822 size 4286 envelope. IMAP4 Rev1 WGMTG summary and minutes. // B27397-010000 at cac.washington.edu, body nil NIL 7 BIT 3028, 92, S, A003 OK fetch completed, C, A004 fetch 12 body, header, S, 12 fetch, body, header 342, S, date. Wednesday 17 July 1996 2:23 and 25 seconds -0700, S, from, Terry Gray at cac.washington.edu, S, subject, IMAP4 Rev1 WGMTG summary and minutes. S, 2, imap@cac.washington.edu, s, cc, minutes at CNRI Reston VAUS, John Clenson at MIT.edu, s, message id, B27397-010000 at cac.washington.edu, s, MIME version, 1.0, s, content type, text plain. Charset equals US ASCII, s, A0040K fetch completed, C A005 store 12 plus flags / deleted, s, 12 fetch, s, A0050K plus flags completed, C, A006 logout, s, by IMAP4 Rev1 server terminating connection, s, A0060K logout completed. See also, list of mail servers, comparison of mail servers, comparison of email clients, Post Office Protocol, Push IMAP, Simple Mail Access Protocol, ABMail, IMAP idle, references. Further reading, Heinlein, P. Hartleben, P. The Book of IMAP, Building a Mail Server with Courier and Cyrus. No Starch Press. ISBN A1-59327-177-8. Hughes, L. Internet Email Protocols, Standards and Implementation. Artec House Publishers. ISBN A0-89006-939-5. Johnson, K. Internet Email Protocols, A Developer's Guide. Addison Wesley Professional. ISBN A0-201-43288-9. Loshin, P. Essential Email Standards, RFCs and Protocols Made Practical. John Wiley & Sons. ISBN A0-471-34597-0. Mullett, K. Managing IMAP O'Reilly Media. ISBN A0-596-00012-X. Rotom, J. Programmer's Guide to Internet Mail, SMTP, POP, IMAP, and LDAP. Elsevier. ISBN A1-55558-212-5. Wood, Deprogramming Internet Mail. O'Reilly. ISBN A1-56592-479-7. External links, IMAP Protocol Mailing Lister, RFC 3501, Specification of IMAP version 4 Revision 1, RFC 2683, IMAP Implementation Suggestions RFC 2177, IMAP 4 Idle Command.